裂。我们看看啊，这个球打安打没有问题啊。打到的瞬间，棒子已经裂了，已经裂了，然后
是断棒打到黄浩然，哎呦，
其实还好了，
这个
其实还 OK 了，坦白讲，
要换捕手了，要换捕手了。
我是觉得说还 OK 了，因为这个有戴头盔了，可能一时会觉得晕眩了哦。但是断掉的是一个棒子的，不是那个粗的部分，是比较细的部分去敲到的。
Our first baseball myth's a real corker.
Man, how great is it to have Roger Clemens helping us do baseball myths?
Yep, can't wait to see him do his stuff.
Well, our first myth is a total classic, the corked bat.
What's a corked bat about?
Here's the idea. You drill a hole in the end of a normal regulation Major League Baseball bat, you put some cork in there, you plug it back in with wood, and that bat is all of a sudden able to hit balls a lot farther.
Is that legal in baseball?
It's ever so slightly totally illegal.
Huh.
You bet it's illegal. In 2003, the baseball world was rocked when star slugger Sammy Sosa's bat split during a game, exposing a cork core. He claimed it was a practice bat he'd picked up by mistake, but Sosa was immediately ejected from the game and suspended for 7 matches.
What do you think our general plan is?
Well, we get a bunch of bats, figure out how to cork some of them, and see which one will hit a ball further.
I think we should remove the human element from this as much as we can. Let's make a machine that swings the bat at the exact same speed every time.
Yeah, and while we're at it, we need to do the same sort of thing with the ball, only we can use a cannon instead of the swinging machine.
You know what? I'm thinking that we've already built everything we need to test this myth for previous episodes. We don't need to go out anywhere. It's all right here in the shop.
Yeah, a few modifications maybe, but they'll work.
Excellent.
Ladies and gentlemen, it's a Mythbusters first. No blueprint diagrams, no time-consuming builds. This baseball myth will be totally off the shelf.
Cary Grant and Torrey built a sword swinging rig when they were doing sword cutting a sword. That's perfect for swinging a baseball bat. And 2, Jamie and I already built an air-powered cannon. That is so wrong. Which is perfect for throwing baseballs at speeds well up to the supersonic range, I think. All right, here we go. I'm flicking the switch.
First, a test firing, just to blow away the cobwebs.
That's a nice download, man. That is fast.
Now, a Roger Clemens fastball fizzes towards the batter at between 90 and 100 miles per hour.
There we go.
But Adam and Jamie will go for a more average fastball speed, about 80 miles an hour.
Let's just quickly try 7 psi.
The air pressure required to do that is around 7.5 pounds per square inch.
At
7.5 psi.
Here we go.
79 miles per hour. Close enough. Next, gotta get the batting rig into the swing of things.
I'm going to swing this bat on high-speed camera, and we're going to measure how fast it is and calibrate this machine so it swings the bat just as fast. All right, let me give my hands a moment to recover. And my dignity.
Take your time, buddy. We could watch this all day.
Can we move on to something else now? Let's cut to me swinging. Here we go. Cut.
Adam's clean swing clocks 62 miles per hour. That equates to air pressure of 70 psi.
Okay.
All they have to do now is cork some bats. But baseball authorities don't want us to show exactly how that's done. And as Adam tampers with the timber, he's wondering if this whole quirky cork caper isn't a case of mind over matter.
Since 1970, 6 major league hitters have been caught using a corked bat. Kind of makes you wonder if there's something to it.
Well, the act of corking a bat does remove some weight, but if you want to swing with a lighter bat, there's nothing in the regulations that prevent you from just going and getting a lighter bat.
Then why do it?
Well, to a major league hitter, the psychological advantage may be huge. If you believe your bat has special power, you may be more likely to get that hit.
And that could be the difference between being struck out or making a home run.
Exactly.
The pitching cannon is primed, ready to fire. The bat bot is poised over the plate, all set to swing. Better stand back, because Jamie's workshop is about to become a batting cage.
And we're going to put up a net. Aren't we putting up a net? I think we're going to put up a net. And she's really good at catching balls.
Testing baseball myths with cannons and robots. Isn't that so, Mythbusters?
Something's going to go someplace where it shouldn't. We're going to have mayhem and destruction one way or another. Yeah. Oh, but what the heck? It's all in the name of science.
Meanwhile, Adam and Jamie have been putting a cork in it. Now, the rules of baseball state that a bat must be a single piece of wood. That's how they leave the factory. But in the search for more spring, some players hollow out bats, replacing wood with cork. But does cork equal clout? I'll just let Adam explain.
The heart of this experiment is a timer. One that fires a ball, one that swings a bat. Here's how it started. I release the safety, I click this. This sends electrical signals all the way down here, follow me, to our bank of air tanks, which we built for the Pirate Special Cannon. These two solenoids are activated by that timer. They activate these valves, releasing all the air from these tanks into the bottom of this barrel, in which is one of these balls in a sabot. The ball starts traveling down the barrel. As the ball travels down the barrel, a second electrical impulse activates this quick release on a valve, which releases this bat, which is on a spring on this cylinder here, swinging all the way around. Hopefully, at the very moment the ball is leaving the barrel, hitting the bat right at the point of impact we want, capturing it on high-speed camera, knocking it out of the park, and answering our question once and for all.
The reason we're doing it this way is we need to isolate the effect of the cork. Now, if the bat is swinging at the same speed each time and the cannon is firing the ball at the same speed each time, the only variable here is the corked bat. And that should make it really obvious if the corked bat is providing extra spring.
First, a regulation uncorked bat. The cannon is lubed with lard and a baseball loaded, snug in its foam sabot. We're ready to play ball.
I'm going to fire both of these things at precisely the same second.
Okay.
The tricky part of this experiment is the timing. The ball will be flying at 80 miles per hour and the bat swinging at 60 miles per hour for a combined collision speed of 140 miles per hour. If Adam's timing is out, even by a couple of milliseconds, the two won't connect.
In 3, 2.
Strike one. Cannon and robot weren't in sync, but never fear, the game's not over yet.
High speed says that we've dialed into our correct batting speed. The mechanical bat is swinging just as fast as I was able to, 62 miles an hour. However, the ball is showing up to the party 141 milliseconds early.
Adam tweaks the timer.
I've delayed the ball by 141 milliseconds. Everybody ready? In 5, 4, 3. Hey, we hit it! Woo!
This time, Adam's timing was spot on, but the ball rocketed off the bat and smashed a chunk out of the scale.
Ground ball.
Ground ball. So that may mean that this test is invalid because it hit this.
Yeah.
And we don't get a measurement of how fast the ball leaves there.
The guys reset.
Go. That's the hit!
This batting robot's really got its eye in.
Oh, it's another good hit. Yeah. Oh.
It hit one side of your shop and then the other.
Oh, there it is. It's in the armature wire.
That's great.
Now that we've seen a number of hits with a regulation bat, what the high-speed camera is telling us is that the ball is consistently leaving the cannon at 80 miles an hour, which happens to be about the speed of a Roger Clemens pitch. It's also leaving the bat once it gets hit at 80 miles an hour. The next thing we need to do is test how fast it leaves the bat when the bat is corked. If it leaves faster, that'll answer our question.
3.
That was a hit.
That was a hit.
The ball is over here.
And the bat is still there. So, with any luck, that's data. The ball is coming into the bat at about 80 miles an hour, but it is leaving that bat at half that speed, at about 40 miles an hour.
Remember, when they tested the regulation bat, the ball was arriving at 80 miles per hour and leaving at almost the same speed. Try again.
That looked like a beautiful hit. That looked like a perfect line drive back towards your welder. That's perfect. That's as good as our best one with the non-cork bat. Our earlier data points with the normal uncorked bat had the ball leaving the bat pretty much at exactly the speed it was going towards the bat at. And these, in both of our good data sets on the cork bat, it's leaving at half the speed.
Loading your lumber with lightweight cork poses two problems. The bat might be lighter and easier to swing, but reduced weight means less energy delivered to the ball. Also, instead of adding extra spring, the cork actually absorbs some of the impact. Those two factors add up to blunted batting ability.
A ball hitting a cork bat is going to leave that bat at a slower speed than a ball hitting a regulation unmodified bat. I mean, they made this thing to hit a ball really efficiently. I don't think it warrants any modification.
Looks like this baseball myth's been knocked out of the park.
Guess what?
What?
I made a commemorative plaque for this myth.
Corked bat, okay.
Yeah.
Well, you know, one way or another, it looks like the guys that got caught using a corked bat got themselves suspended for nothing.
Yeah, you know, while our sample size might have been small, our results were totally unambiguous.
Now, every time a ball came off the corked bat, it was coming off at half the speed that it was off of a normal bat.
Yeah, far from acting like a spring, it was a lot more like a sponge. I gotta say, this one is totally busted.
Totally. It's busted.